Hello everyone, I'm Professor Sahebgouda Patil, Department of Computer Science and Engineering, BLDEACET Vijaypura. So I welcome you all for this cloud computing lecture. So in this lecture, I'm going to cover the following topic. The first topic, that is layering and virtualization. Then second one, virtual machine monitor. So I'll be covering these two topics in the today lecture. So move on to the first one. We'll see the layering. So what do you mean by layering? Layering, it's a common approach. It's a common approach to manage the system complexity. So what do you mean by layering? Layering, it's a common approach to manage the system complexity. It's a common approach, as I told you, to managing the system complexity is to identify a set of layers. So that is what we call it as a layering. So this with the well-defined interfaces among them. So along with this, it also uses the well-defined, defined interfaces. So interfaces. So we can see in detail in the later part. So what are the interfaces that we are going to discuss? Okay. So layering, which also minimizes the interactions among the subsystems of complex system. So which also simplifies the description of the subsystem. Each subsystem is abstracted through the interfaces. Abstracted to what? Interfaces with the other subsystems. So with that, we can able to design, implement, modify the individual subsystems independently. So though we have the abstraction to the its interfaces, with the help of the interfaces, we can able to design, we can able to implement and modify the individual subsystems with independently. So this is the brief introduction about layering. So along with this, we have the concept that is with respect to layering are hardware and the software. So what do you mean by this hardware concept that we can see? Hardware which supports two execution mode. So what are those? The one is kernel mode, then another one is user mode. Another one is what? User mode. A privileged set of instructions. There are two kinds of instructions are there. One is privileged instructions, another one is non-privileged instruction. One is privileged instructions and another one is non-privileged instructions. Okay. The instruction set consisting of two sets of instruction, that is privileged and non-privileged. The privileged instructions that can only be executed in kernel mode. Remember this. So these privileged instructions that can be executed only in the kernel mode, and non-privileged instructions that can be executed in user mode. Okay. So this hardware consists of one or more multi-core processor. Along with this, it also consists multi-core processors, and it also contains a system interconnect, like interconnecting using the buses. So we use buses, one or more buses for interconnection of systems. Memory translation unit, we call it as a MTU, that is memory translation unit. The main memory, IO devices, including one or more networking interfaces. So it also includes IO devices as well. Okay, it also includes main memory and networking interfaces. Okay. Along with this, we have the software as well. So this software which contains the operating system, libraries, and applications. These applications written mostly in high level language, that is we call as a HLL. Okay, often called library models, and are compiled into object code. Okay, so using this high level language, so we are going to compile into the object code. So we can see in detail with the pictorial representation the how HLL can be converted into the object code. Okay, hope you have understood this. Move on to next, interfaces. So there are mainly three interfaces are there. The first one is instruction set architecture. Then second one, application binary interface. Then third one, application program interface. So we can see one by one in detail. The first interface we discussed is the instruction set architecture. So instruction set architecture, it is at the boundary of the hardware and the software. So it is at the boundary of the hardware and the software, hardware and the software. So this is about instruction set architecture. Then we have next interface is the application binary interface. Application binary interface, which allows the ensemble consisting of the applications, which mainly consisting of the applications and the library model and the library models. So ABI consists of applications and the library models to access what? To access the what? Hardware. To access hardware. Okay. The ABI does not include privileged system instruction. This ABI, it does not include privileged system instruction. Instead, it invokes the system call. Instead, it invokes the system calls. So this is about ABI, that is application binary interface. The next, finally, the third one, we have the API, that is application program interface. So API, which defines the set of instructions the hardware was designed to execute and gives the application to access the ISAs. So which gives the application to access what? Instruction set architecture. It includes HLL library calls. Sorry. Okay. So this includes HLL library calls, which often invokes the system call. This often invokes the system calls. This is all about the application program interface. So we have gone through the three interfaces, that is ISA, ABI, and API. So move on to next. So we have the pictorial representation of layering and interfaces between the layers in a computer system. So already we have gone through the interfaces, that is API, ABI, and instruction set architecture. So in this, the software components, including the applications. So these are the applications. Then we have the libraries and operating system. So these interact with the hardware. So all these what? This will be, just look at the arrow mark here. So these will be interacting with the hardware. Interacting with what? Interacting with the hardware via several interfaces. The several interfaces like API and ABI and ISA. Okay. The application programming interface, that is also one of the interface. Then application binary interface, that is ABI. Then we have the ISA, that is instruction set architecture. Okay. An applications uses the library functions. So what are the library functions? That is A1. Okay, what it does? A1 makes system calls A2. Okay, A1 what it does, it makes system calls to what? A2. A2 and executes the machine instruction A3. Okay, what it execute? It executes the machine instructions that is done by who? A3. Okay, so this is the pictorial representation of layering and interfaces between layers in a computer system. The next concept, that is code portability. So what do you mean by this? Here, clearly the binaries created by a compiler for a specific ISS. Okay, what is this? For a specific ISS and specific operating system. The one which is created by a compiler for a specific ISS and specific operating system that are not portable. Remember this. So those are not portable. Which are not portable? The one which is created by compiler for a specific ISS and specific operating system. Those all are not portable. Such code cannot run on a computer with different ISAs. So such code cannot run on a computer with a different ISA or on computers with the same ISA but different operating system. What? Same ISA with different operating system. However, it is possible to compile. It is possible to what? Compile HLN programs for virtual machine environment where portable code is produced. Okay, where it is produced? Where the HLN program for a virtual machine environment, portable code is produced and distributed and then converted by binary translators to the ISA of a host system. So in this case, it is not possible, but here the code portability can be done. A dynamic binary translation converts blocks of guess instructions from the portable code to the host instruction and leads to significant performance improvement. So this is one of the advantages of dynamic binary translation, which significantly improve the performance as such blocks are cached and that can also be reused. So this is all about code portability. So next we have, I was talking about HLN code. So this HLN code, okay, it is called as a high level language code. This can be translated for a specific architecture and operating system. So this is what translated for a specific architecture and operating system and operating system. HLN code can also be compiled into portable code. So this HLN code, this can be compiled using the compiler into portable code. So, and then the portable code translated for systems. This portable code translated for what? Systems with different ISAs. There will be we having the different ISAs. With the help of these different ISAs, this portable code can be translated for the systems. The code that is shared distributed is the object code. Remember, the object code can also be shared and distributed. In the first case, this is we call it as the first case, and this is we call it as a second case with respect to HLN code. And the portable code in the second case can also be distributed and shared. So in the second case, that is portable code can be distributed and shared. In the first case, the object code can be distributed and shared. So we have the loader here, finally, which loads memory images to the disk. And here we have the VM virtual machine image. We have the compiler as well as the interpreter that is going to store memory images into the ISA1, that is instruction set architecture 1. So this is all about high-level language code can be translated for a specific architecture and the operating system. Hope you understood this. Thank you so much for watching the video. Please like the video, subscribe the channel and share the video. Thank you everyone.